The last application that I'm gonna talk about is called transformer. So what's a transformer? Transformer will transforms the voltage from one value to another. So say this is usually what happens. So you definitely have seen a lot of generators in your life. You just probably don't pay attention to it. But if you ever walk outside to do the grocery shopping, you may see some bugs on the what's that, the electric poles. Okay, so this is the electrical pole. I don't know how to call this, like the poles. Like you can see it everywhere, and the poles will have a wire connected to your house so that you can use the electricity. And this guy is called transformer. There are some like larger transformer where you can see at the countryside. Okay. So basically, this transformer is what the job of the transformer is try to transform the voltage from one value to another without losing the power. So for example, the power plant has used a generator to generate a lot of electricity. And eventually that electricity must be sent to your house so that, so that's why you're paying the bill, right? So, but the power the voltage coming from a generator is tens of thousands volt, which is not what you want to do at home. That voltage is too dangerous. So when you want to transmit this voltage, this current all the way to your house, we usually don't just transmit it. First, we will use a step-up transformer to increase the voltage even higher, up to like 400,000 volts, and by using a step-up transformer. And when it is closer to the city, then we will use a step-down transformer to decrease the voltage. Then just right before it's sent to your house, we will decrease it from thousands of volts down to 240 volts so that you can use it. And the reason that we want to keep this transmission at such a high voltage is because we want to reduce the power. We want to reduce the waste on the wire. Okay, so exactly how do we design such a transformer to convert the voltage? So remember that usually we know the voltage can only change, say if we go through a resistor. If I have 240 volts here, and after current going through it, then this will become, I don't know, like 120 volts. But when you do this resistor will steal some energy, right? If this is a light bulb, it will be lit up and dissipating the energy as light. So usually this guy will steal some of the energy, and we don't want that. We want to have some sort of transformer which can convert the voltage without losing power. That's the goal. And to reach that goal, this is a very beautiful design which can fulfill this purpose. So let me explain this design to you. This design is basically includes two circuits. So first, one circuit will come in from here. Okay. So this is the power plant. This is your house. Okay. So circuit one, I'm gonna call it primary circuit, and this end I'm gonna call it secondary circuit. The primary circuit will send out a voltage which has will send out current with the voltage VP. And my goal is to convert that voltage from VP to VS. Okay, and this is my design. So let me see, so let's follow the current and see how it goes. So first my current will coming in, right? So say, Oh, sorry, the current is going the other way. Okay. So first, my current coming into this primary coil. This we call this the loops. We call this coils. So fat. Let me use a skinnier one. Coil. Okay, and this coil will wrap around this this bar. So you can see my current is coming in. So what does it look like? Well, coming in this way. So coming this way. Coming in this way. Okay. And then eventually come out here. So you can see my current is going this way. And if I have a current wrapping around an iron bar and then going that way, you can imagine that it's gonna create a magnetic field going downward. And since this field is downward, right? And this field is, and this entire thing is all iron bar, is all iron, made of iron. So the magnetic field are going to just travel inside this iron. So it's gonna come over here, hit the boundary and keep going. And then keep going. So for this loop, initially there's no current. There was no current. There's no magnetic flux. But now, once the current comes inside from the primary coil, it's gonna feel the magnetic field induced by the primary current. So this guy, the right-hand side, the loop, all these coils are going to experience a change in magnetic flux. So this coil, you can imagine, you can imagine that before it's nothing, after it has a lot to the up. So to counter that upward magnetic flux, it's gonna create a downward magnetic field to oppose it. So the downward magnetic field will oppose it by induced current going in this way. Okay, it's gonna go in this way. And because it's going in this way, because he wants to counter it, so and then such that the current will come out from here. Okay, yeah, it's coming out from here. All right. Okay. All right. So now you can see, let's review the process first. The electricity is generated by the power generators, and this generator will send in the current. This current will create an electromagnet here. The electromagnet will induce magnetic field in another coil, and because the change in magnetic flux, this second coil will induce another current, which is the current going to going through the secondary circuit, which is your house. So basically, you can see, okay. So basically you can see that this guy are going to create some magnetic flux. That flux change will be the same as the change here. And so that's it. And if we look at this problem in more theoretically, you can see my input voltage. My input voltage will create my input voltage. My input voltage will create what's that? The flux change. Okay. And each loop will create a flux change like this. If I have NP loops, then I will create a total flux change like this. Okay. And similarly, I can look at this. Similarly, I can look at the second part. The second part, I will also induce the voltage, which we call secondary voltage. Each loop will experience a flux change as delta phi over delta t. Now you have so many loops, so you will totally. So this will be the total magnetic flux change that you will experience, which is your voltage. However, you can see that the flux change through each loop are going to be the same because this is a closed magnetic field. This guy, it's a closed magnetic field, right? So whatever change here experienced by one loop will be the same as the magnetic field change here, magnetic flux change here experienced by another loop. So the delta phi over t and delta phi over t will be the same in both cases. Therefore, we can how do I put this? We can put this over, we can put this over, and then equate these two equations, and you will get the simple transformer relation. It simply tells you that the voltage is proportional to the number of coils. Okay, so basically this is a very smart idea. So say, I'm gonna clear up all the drawing. So let me give you an example. Let's say here, I have 120 volts coming in. Say I want to have a 240 volts going out. How would you design your transformer? Basically, you just make sure the number of turns, the ratio of the number of turns between these two is 1 to 2. So say if you have 10 turns here, 10 loops here, you just make sure that you have 20 turns. Then you can make this happen. Okay. And during this process, you can see there's no current. This magnetic flux here is completely safe. There's no friction, and it's impossible to have any. It's not impossible, but it has very little friction, and there's almost no power lost during this transforming process. Because what I'm propagating is not current. Current can lose energy easily, but if I'm propagating a field, then that's not something can be easily lost. Okay. And since the power cannot be lost, and we know that P equals to IV, so we know that the primary power should be the same as the secondary power. Which means that you can see the voltage is inversely proportional to the current. Okay. All right. So it's all kind of like all together. You can see this unit we are starting to combine what we learned before about the circuit, about magnetism, about electrostatics. Everything is kind of all together. All right, this is the last one, and I hope you had fun with that.